Hello viewers, in this video we are going to learn about log-based protocols in concurrency schemes. Hello viewers, in this video we are going to learn about log-based protocols in concurrency control schemes. Log-based protocol is one of the concurrency control schemes that controls concurrent access to a data item in a mutually exclusive manner using logs. That is, while one transaction is accessing a data item, no other transaction can modify that data item. This is what known as mutually exclusive access to a data item. This log-based protocol permits a transaction to access a data item only if it is currently holding a lock on the data item. Suppose if a transaction is not holding a lock on the data item, that is not permitted to access. Okay? So in this way, log-based protocol controls access to a data item by multiple transactions only if they are holding a lock on that data item. Okay? Here, a concurrency control manager component of a database management system is responsible for implementing any concurrency control scheme, including log-based protocol. Okay? In log-based protocols, concurrency control manager, it permits the transactions to access the data items in two modes. One is exclusive mode, another one is shared mode. If suppose a transaction would like to perform read as well as write operation on a data item, then it has to hold a exclusive lock on it. Okay, this exclusive lock is requested using lockx instruction. Okay, if suppose a transaction would like to do only read access on a data item, then it has to acquire the lock on shared mode. Shared lock is requested using lock s instruction. With this instruction, it can request for slock, that is lock in shared mode from concurrency control manager. Here, concurrency control manager uses lock compatibility matrix for granting of locks whenever a transaction requests for locks. According to this lock compatibility matrix, whenever a transaction is holding locks, shared lock or exclusive locks, that is, if suppose these locks are currently held by transactions. If suppose currently one transaction is holding shared lock on a particular data item, at the same time, if another transaction is requesting for shared lock, if suppose one transaction is holding shared lock on a data item, and if another transaction is requesting for shared lock on the same data item, both are considered as compatible, so that request will be granted. The meaning of this is that since shared lock is used for a read operation, then I mean multiple transactions can perform read operation on a same data item at the same time, right? So even though number of transactions performs read operation on the same data item, it will not violate the consistency property and they are considered as non-conflict operations. That's why whenever a transaction is holding a shared lock on a particular data item, if any other transaction is requesting for a lock in shared mode, that will be granted. And let us take one more case. Whenever a transaction is holding shared lock, if another transaction is requesting for a lock in exclusive mode, then both are considered as conflict, that is incompatible, then that request will not be granted. And let us take one more case. Whenever a transaction is currently holding a lock in exclusive mode, and at the same time, whenever another transaction is requesting for shared lock on the same data item, then this exclusive and shared both are considered as incompatible, that is, they are conflict. That's why this request will not be granted. And one more one more case. So whenever a transaction is holding a lock on exclusive mode on a particular data item, and at the same time when another transaction is requesting for um, lock in exclusive mode, that is considered as conflict and incompatible, and that type of request will not be granted. Students, you can observe here, we already learned that conflict operations and non-conflict operations. Um, so read on data, read operation on the same data item is not conflict. That is the reason, since for read operation, yes lock is needed, and that's why when multiple transactions are doing um, read operation, then that is considered as non-conflict. So they are permitted to do at the same time on the same data item. Okay, but whenever one of the operation is a write operation, so for example, read on queue and write on queue, and write on queue and read on queue, then write operation on queue. So these three combinations are considered as conflict. So uh, this conflict operations, whenever it is found here, they are considered as conflict and incompatible. So that type of access will not be permitted according to the lock compatibility matrix. So how it is illustrated here in this lock compatibility, that is for read on queue, we need shared lock, right? So whenever one transaction is holding a lock on S mode, shared mode, if another transaction is requesting for performing a write operation, so for that it has to get exclusive lock, right? So since these two are conflict, um, uh, this request will not be granted. Okay, in the same way you can understand the other cases also. Okay, so lock compatibility matrix is implemented by concurrency control manager in order to ensure either the request for lock is compatible with the existing lock or not. If that is not conflict, then that will be granted. And there is a lock can be granted if there is no other transaction holding a lock on queue that conflict with the requested lock. Okay. So whatever we discussed now on log-based protocol is a simple log-based protocol. So in this, though the concurrency control manager uses logs to achieve concurrency control, there are a few pitfalls occurs in this method. One is inconsistency in the database may occur, that occurs due to too early unlocking, and it may also lead to deadlock problem that occurs due to too late unlocking. And this simple log-based protocol also may cause starvation problem, and this occurs due to badly designed concurrency control manager. So let us discuss these problems with suitable examples. Um, Here this example is taken to highlight the inconsistency occurrence in the database. Here one non-serial schedule is taken. Here why it is called as non-serial schedule? Because before the completion of the entire transaction T1, T2 is permitted to execute. T2 is permitted to execute. That's why it is a non-serial schedule. Here a log-based protocol is implemented. So according to log-based protocol, a transaction is permitted to access any data item if and only if it is having a lock on it. Okay, so we can notice here transaction is performing the read operation on EA. So before performing this, we can notice here it send request for acquiring lock on exclusive mode. So the meaning, why exclusive, in exclusive mode it is requesting, it is not only performing the read operation on A, here we can notice it performs write operation A. Since it performs both read and write operation on A, it requests for exclusive lock. Okay, so when this request is made by T1, this lock will be granted. This lock request will be granted because no other transaction in this same schedule is holding a lock in conflict mode. Okay, since there is no other transaction is holding lock, so it will be granted immediately. So now this transaction T1, it got access right to perform read as well as write operation on A. Okay, so now it performs read operation. So initially assume that A and B values in the database are 1000 and 2000. Okay, whenever the transaction performs read operation, it reads the value of A as 1000, and after the execution of this, it is um, the 1000 value A minus 100, right? So after subtracting 100, this A value becomes 900. So it performed both read and write operation. Then after that, it unlocks because it performed it operation, both the operations. So it unlocks the lock on A. Okay, so right now no transaction is holding lock on A. Okay, so meanwhile T2 would like to perform a read and write operation in order to display the summation value of A and B. So for that, it is enough to perform read operation on A as well as B. So it send a request for acquiring a shared lock on B because it wants to do read operation, right? So it sends a request for acquiring shared lock on B. So since there is no other transaction is holding lock on any of the data item right now, this request will be granted by concurrency control manager. So once the lock is granted, it performs the read operation on B. So after performing its operation, it unlocks it. Then again, it wants to do read operation on A. So for that, it sends a request, lock request, shared lock request on A. So immediately this request also will be granted by concurrency control manager. So once it is granted, it can perform operation on A, read operation on A. So here students, you can notice here whenever it performs the read operation on B, currently the value of B is 2000. That value will be read by this T2, and when it reads the value of A, here in this after this instruction the value has been changed, and when this write operation is performed, this value might be changed into 900. So now this value only will be read by this T2. Okay, so when it performs the read operation, it will read the latest updated value 900 that was updated by T1 after the write operation on A. Okay, so when after read operation, it unlocks it, and when it displays the value of A plus B, and it gives the result 2900. So the what is the value of A? 2000, and what is the B value it read? 900. So the sum value would be 2900. And after that, here this instruction must come up. Okay, lock exclusive on B. Okay, students, after performing this, again T2, it resumes its operation. That is, it wants to do a read operation on B, a write operation on B. That's why it has to acquire exclusive lock on B. Okay, so for getting exclusive lock on B, it send lock request for in exclusive mode on B. This instruction is used. Then once it is made, it will be immediately granted because no other transaction is holding a lock on any of the data item. Here this transaction also unlocked the lock on A, and this also unlocked, and T2 also unlocked on both the data items A and B. So no transaction is currently holding lock on any of the data item. So this request will be granted, and now it can perform read operation. When it reads the value, it observes that B value is 2000, and the same value will be read. And after this B equal to B plus 100, the B value becomes 2100. So when this write operation is executed, this 2000 is updated by with the value 2100. Okay, so then after doing its both read and write operation, it unlocks the lock on B. Okay, so once all the operations are performed, let us check the consistency of this schedule. Okay, so initial value of A and B are 1000 and 2000. Its summation is addition value is 3000. So at the end of this transaction, what is the result of A plus B? This is 900. The last value, I mean, according to the after update, the latest value of A and B are 900 and 2100. So it's okay according to T1. But when we come to transaction T2, when it performs A plus B, its value must be 3000. But what value we got? 2900. Since this 2900 is not equivalent to 3000, it violates the consistency property. So why this violation happens? Because too early unlocking of the locks. Here you see whenever the transaction completes its operation on any particular data item, immediately they releases its locks. So that is the reason this schedule faces consistency problem. Okay, let us take one more problem that is caused by uh, lock-based protocol. Okay, here it is the partial schedule. In this first transaction, it um it send the request for lock request on for data item A in exclusive mode. So when it sends this request, immediately this request will be granted. Students, you know why? Because no other transaction in this schedule um, is holding lock at this time. Okay, so immediately this lock request will be granted, and after some time, T2 would like to do read and write operation on B, so that's why it sends the lock request for B in exclusive mode. Okay, this also will be granted because so as of now T1 is holding lock on A only, not on B. So no transaction is holding lock on B. So that's why this lock request will be granted. Okay, then after some time T1 would like to perform read and write operation on B. So that's why it sends a lock request in exclusive mode on B. Okay, so now can you guess either this request will be granted? Um, the answer is no. You know why? Because currently T2 is holding exclusive lock on B. So when T2 is holding exclusive lock on B, T1 is requesting for exclusive lock on the same data item B. Okay, so exclusive lock, I mean lock in exclusive mode and another lock in exclusive mode. These two are conflict, incompatible. That's why this request will not be granted. This lock will not be granted. So it has to wait to perform its operation. It has to wait until the lock is granted. So it will be waiting for the release of this lock by T2 on data item B. Then meanwhile, a T2 would like to perform read and write operation on A. So for that, it also makes a lock request in exclusive mode on A. So, so now also this request will not be granted because already T1 is holding exclusive lock on the same data item A. So since already there is a lock on same data item in conflict mode, X and X are conflict, right? So this request will not be granted. So T2 has to wait for T1 for releasing of lock on A, and T1 is waiting for T2 for releasing of lock on B. So both are waiting for each other and none can proceed further unless any one of the transaction rollbacks and releases its locks. So this problem leads to deadlock. Okay. Next problem that is caused in simple lock-based protocol is starvation problem. Starvation is the situation when a transaction has to wait for indefinite period of time to acquire a lock. For example, a transaction may be waiting for an exclusive lock on a data item while sequence of other transaction requests are granted an S lock on the same data item. Students, for example, you assume that a transaction T1 is um, made T1 has made a lock in a shared mode on A. Okay, so when it made the request, it will be immediately granted because no other transaction is currently holding any lock on the data item A. Okay, so this is the first step, and in second step, I mean after some time, T2 is requesting for lock on same data item but in exclusive mode. But by the time T1 is holding lock on A in shared mode. Since exclusive mode and shared are conflict, this request will not be granted immediately. So it is waiting. It is T1 is waiting for the release of lock on A by T1. So by the time T3 enters and it requests for shared lock on A. So this request, it will be granted now, though T1 is holding a lock on A, because shared and shared are compatible, it is not conflict. So this request will be granted. So currently T1 and T3 are holding shared lock on A because multiple transactions can perform read operation on the same data item. Okay, so meanwhile, when T2 is waiting for exclusive lock in exclusive mode, T4 enters and it is also requesting for shared lock. And meanwhile, T1 or T3 may have released its lock. Okay, then T4 is requesting for shared lock um, uh, in shared mode on data item A. So this will be granted because either T1 or T3 may any one of the transaction or both may have a lock on that. Okay, so anyhow either it is holding or not holding, that doesn't matter. This request will be granted. So you can see in this way T5 also may request, T6 also may request shared lock on A. So that will be granted, but this T2 is waiting until the release of all the shared lock on A. So it leads to starvation problem. Okay, so this type of problem can be resolved by carefully designing the concurrency control manager. Okay, so concurrency control manager has to be designed in such a way to grant lock by following two rules. Okay, so the first rule so far, we already discussed, that is what followed in simple lock based protocol. What is the rule? Um, there is no other transaction is holding a lock on a data item in a mode that is conflict with M. So whenever a transaction is requesting for a lock, if no other transaction is holding a lock in conflict mode on the same data item, that is granted, right? So this is what we already discussed. But in addition to this, the concurrency control manager also has to ensure one more. What is that? There is no other transaction that is waiting for a lock on queue. Okay. Uh, if there is no other transaction that is waiting for a lock on queue and that made its lock request before TI. Okay. In such case, if no other transaction is waiting for the lock on queue, then only the lock request can be made to any of the transaction. Okay, students. So what are the two rules need to be followed? If whenever a transaction is requesting for a lock, the concurrency control manager has to ensure that no other transaction is holding a lock on the same data item in conflict mode, and no other transaction is that is waiting for a lock on the same data item. So that's why if we do in this way, this students, in this video we learnt about simple lock based protocol, how it controls the concurrent access to a data item by multiple transactions, and what is the use of compatibility matrix, how it is utilized by concurrency control manager, and the problems that are arises due to early unlocking of locks and late unlocking of locks and starvation problems that occurs in simple lock based protocols. If you find this video useful to you, kindly subscribe this channel. Thanks for watching.